Hi everyone, Chapter 3, Section 3. Today we're solving inequalities again, but we'll be doing it using the property or the operations of multiplication or division. Today I'm just going to give you a heads up here as we go through the notes. Lots of examples. I'm also going to have you work through examples in your workbook so that we've got then a whole repertoire of examples that we've gone through so that when you see certain situations arise, you've got your resources right there and you can say, aha, we did one just like that, I know what to do. Okay, so be forewarned, you'll need notes plus your workbook here in just a little bit. So what I want you to do is I want you to write down this inequality, but I want you to write it twice. I want you to write it side by side. 4 is less than 7. Then write 4 is less than 7. Because I need to illustrate what happens here when we do some multiplying. All right, like yesterday, we discovered that things were staying the same, or we were preserving this property of inequality when we multiplied both sides, or added or subtracted both sides of the inequality by the same thing. And today we're going to test it with multiplication. So let's multiply. And I'm just choosing 5. And let's see what happens. On the left side, I get 20. On the right-hand side, I get 35. And sure enough, 20 is less than 35. Hot diggity dog. Even if I picked something huge, like let's say I chose 100, and I multiplied both sides by 100, you get 400 on the left, you get 700 on the right. Sure, those are still less than. So it appears that, yes, multiplication is going to hold true the same way. Well, hold your horses here. I want you to come over to this one, this duplicate 4 is less than 7 inequality on the right-hand side here. And what if I told you multiply by negative 2? And then come over here and multiply by negative 2. On the left, 4 times negative 2 is negative 8. On the right, 7 times negative 2 is negative 14. Oh. Hold your horses here. Something went a little kaflooey, because when I look at a regular number line, I know that as I go into negative land here, negative 8 would occur here, and then I'd go further down the line, and negative 14's down here. And actually, negative 14 is less than negative. And because I'm noticing that negative 14 is really less than negative 8, I can't put this less than symbol in here. It really needs to be turned around to say greater than now, because negative 8 is greater than negative 14. Let me test this again. 4 is less than 7. And this time, let's say I multiply by, let's just do negative 1. Okay? And I'm going to multiply this side by negative 1. And I say, I get negative 4. And on this side, I get negative 7. But when I think of my number line, negative 4 isn't less than negative 7 like it was in my initial inequality. I have to invert or flip my inequality symbol now when I'm multiplying by this negative value, because negative 4 is really bigger than negative 7. Very, very interesting. Put a little squiggle line here. That gives us something to think about. Okay, you're going to think I'm crazy again. I want you to write these two exact same inequalities again, side by side. 4 is less than 7, 4 is less than 7. Let's say I divide, and I divide the left side by 2, and I decide to divide the right side. On the left side of my inequality, I get positive 2. On the right side, I'd get 7 halves, which is the same as 3 1/2. Don't let that freak you out. And I look at this and I say, well, yes, 2 is less than 3 1/2. So my relationship seems to be preserved when I'm dividing. However, if I come over here and I divide this by -2, and then I come over here and divide this side by -2. Here's what happens. On the left, I get a value of -2. On the right, I get -7/2, which, by the way, is the same as -3.5, or -3.5. And then I say, oh, whoa, wait a minute here. -2 is not less than -3.5. In fact, it's the other way around. It's a greater than relationship here. So, something very, very different is going on here with regard to my properties and with multiplying and dividing. So here's the big thing you have to watch out for, okay? When you multiply and divide, and we'll call this another property, or properties, I guess, of inequalities. So this is much like yesterday when we talked about adding and subtracting. It turns out adding and subtracting preserved the inequality relationship no matter what you added or subtracted. But it's a little different for multiplying and dividing. Okay? So the first one we'll tackle is multiplying, or just to multiply. All right, multiply. If you multiply each side of an inequality, each side of an inequality by a positive value. The inequality remains true. In other words, the sign stays the same relationship that you started with. If it was less than, it stays less than. Okay? However, there's a little exception or an addition to this situation. Okay? If you multiply by a negative, here's what happens. You need to flip the inequality symbol. You need to flip the inequality symbol. The relationship changes when you multiply by a negative. I guess I can say sign here. If you want to write symbol, that's fine. Okay, so if you multiply, and I should probably add that in here, if multiplying by a negative, it's not just that the number on the other side is negative. All right, if you'll forgive me, I had to retype a little bit here because my computer was going a little bit crazy. So here's where we were at. If you multiply each side of an inequality by a positive value, the inequality remains true. If you multiply it by a negative value, then you have to flip the inequality sign. Okay? The same is going to be true when you divide. So we can come down here and say, basically, the same is true for division. What I want to make sure you understand, though, for division, sorry, it's hard for me to see. All right, so here's what this means. What this means is anytime you're going to solve an inequality, and if you have to multiply or divide by a negative, you'd better flip the sign. So let's look at a bunch of examples, and let's crank through this and get you so you understand when you flip and when not to flip. That's going to be our big question today. So here we go. 6x is greater than 42. Our goal is always get the variable by itself. I'm going to need to divide by 6. Do the same thing on each side. 6 divided by 6 is 1. 1 times x is just x. X is greater than 7. There we go, we're done. Again, I'm going to have you graph these all the time. Here's 7, open circle, shade it to the right. Fine and dandy, everything's perfect. Okay? Here's another one. 4x is less than or equal to negative 36. All right, your algebra antenna should be going beep, 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 because you're looking, I see a negative sign, I got to pay attention here. Here's my symbol. Divide by 4. Divide by 4. 4 divided by 4 over here gives me 1. Sorry. And I get a 1x. Here I get negative 9. Okay, so the math part is done. You have to decide right now, do I flip or not flip? That is the question. We divided by 4. 4 is positive. If you're dividing by a positive number, it stays the same. It stays true. No flipping here. Leave it as less than or equal to. Go ahead, draw your graph as is. Here's the negative 9. Solid circle and shade it to the left. Okay? Next. This one looks very similar. Negative 6x is greater than 42. You'll see, hey, last time I had, I believe, positive 6x greater than 42. Now I'm doing negative 6x is greater than 42. I'm going to divide both sides. This time I have to divide by negative 6. Be fair and do the same thing over there. All right, math-wise, negative divided by a negative is positive. 6 divided by 6 gives me 1s, and 1 times x is x. 42 divided by negative 6 is negative 7. You have to decide to flip or not to flip. That's the question. In this case, we must flip. You divided by a negative, so you have to flip your sign. You should get x is less than negative 7. We're going to get our number line. Here's 0. Negative 7 is down here in negative land. I'm going to have an open circle and shade it to the left. Let's look at this one. Negative 4x is less than or equal to negative 36. First things first, I'm going to get my variable isolated, and to do that I'm going to divide both sides by negative 4. That becomes a positive 1, so positive 1x. This becomes a positive 9. Your question is, flip or not to flip? Because you divided, and you divided by a negative, that means I need to flip my inequality now to be greater than or equal to, so that when I graph this, here's 9. I have a solid dot at 9 because 9 is included in my solution set, and I fill in my arrowhead and shade to the right. Perfect. Let's look at this one. Negative 12m is greater than negative 60. All right. Divide by negative 12. Divide by negative 12. Okay. Negative 12 over negative 12 is positive 1. Positive 1 times m, just m. Goody. Negative 60 divided by negative 12 gives me positive 5. So I got my math done. But I have to ask myself, flip or not to flip? You are dividing by a negative. That means you need to flip your symbol. Your answer should be m is less than 5. Graph it on a number line. You're going to have an open circle at 5. And then because it's less than, you shade to the left and fill in this arrowhead. Alrighty. Think what I'd like it. Oh, we'll do one of these. Oh, I have a fraction for a coefficient of y. Oh, how scary is that? Not at all. Give me a break. 2/3 times y, or if you want to think of it as 2y over 3, that's fine, is less than 5. Now, what I want to do, because I have a fraction here, you can either eliminate or clear the denominator. You could do that by multiplying both sides by 3 first. Then I'd have to divide both sides by 2. Or I can do it in one step if I take the reciprocal of 2/3, namely 3/2, multiply that on the left side of the equation, but then you'd better be fair and do a 3/2 over here. Okay? Now, don't start crying. Don't start getting your knickers in a twist. Fractions are our friends. In addition, 3/2 times 2/3, anytime you multiply reciprocals, you end up with 1. Hello, that's why we picked the reciprocal, because I want a 1y. On this side, 3/2 times 5, well, this is 5 over 1. I get 15/2, or I could think of that as 7.5 if you want. The question is, flip or not to flip? I multiplied both sides, but I multiplied by a positive number. 3/2, even though it's a fraction, is positive. That means your symbol stays the same. Okay? It stays the same. When you go to graph this, here's 0. 15/2 or 7.5 is to the right. This one has to have an open circle because I don't have an equal sign on here. And then it's less than, so I am going to shade to the left and fill it in. Okay? All right, what I would like you to do is get out your workbook and open up to page 21. And let's do a few of these together so you get the hang of it. Okay, page 21, or just look for 3-3. Divide by 4. Divide by 4. This means solving gives me a, and it gives me 8, and you have to ask yourself, do I have to flip it or not? I divided by positive. You should leave greater than as greater than. When you go to graph it, just pick one of these to be 0. I don't care. 1, 2, 3, 4, 5, 6, 7, 8. I suppose I'll be accurate and actually go to 8 here. Open circle, shade to the right. Now, because it's on the workbook, you're going to have to darken this in somewhat, make the arrowhead much bigger, and color it in. Okay? On number 2, this one, you're going to divide both sides by -7. Math-wise, that gives me a positive 1y. Good. 21 divided by -7 is -3. Now you have to ask yourself the question, flip or not to flip? Because you divided by negative, yes, you have to flip. Y is greater than -3. So if I say this is 0, boom, 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 this would be -3. I should have an open circle, and then I'm going to shade greater than, which means to the right, put a big old arrowhead on there. We're good to go. Let's look at the next one. Oh, there's a fraction or decimals here. Ew. Don't worry about that. That's fine. You're going to divide by 1.5. Divide by 1.5. (1.5) divided by 1.5, I get n. -18 divided by 1.5 is -12. And you have to ask yourself, flip or not to flip? In this one, you do not have to flip because you're dividing by a positive 1.5. So on this one, go ahead and think of it as just leaving it as less than or equal to. Go ahead and graph it on here. You can, in all honesty, you can just put a 0 in the middle and pretend you're going by 3s or something. -3, -6, -9. Call this one -12. I'm really just after you're getting it on the proper side. This should be a solid dot this time. Color it in, oops, and shade to the left for less than. Sorry, that's so messy. I wanted to do number 4 with you for sure. It's a -3/8 here, okay? And the way to solve this is really to multiply both sides by its reciprocal. Okay, so we're going to multiply both sides by negative 8/3. Negative 8/3 times negative 3/8 c. And then on this side, I'm going to have to say negative 8/3 times 9. All right, now all of this joyfully ends up being equal to a positive 1c. That's exactly what I wanted, is a 1c here. So I'm just going to write it as c. Over here, let's see, 3 goes into 9 3 times, so it looks like I end up with negative 24. Nice integer. And you have to ask yourself, flip or not to flip? Well, I multiplied both sides by a negative. That means you do, yes indeed, need to flip. So your solution for number 4 looks like c is less than or equal to negative 24. Now here's the deal. Once again, I don't expect you to count 24 spaces here, so go by whatever you want. You know, if you want to go by 6s or 4s or whatever, just go ahead and pick this, negative 6, negative 12. I'm going to go by negative 6s. 6, 12, 18. This would be negative 24 right here. It has to be a solid dot again because I had the equal symbol, and then because it said less than, I need to go to the left and fill in my arrowhead that way. Alrighty? Super. Let's just leave your workbook at that for page 21, and I want to turn you loose now on the book assignment, which is going to be from pages 183 to 185. And this time I'm having you do evens because I want you to come in and check and make sure that you're showing all your steps, and make sure you're watching that negative sign and decide, when do I have to flip? And make sure you're being accurate. Good luck, and we'll check them when you get them done.